Hi, 8th grade. Today we're going to do two lessons. We're going to do lesson 4.1 and lesson 4.2. They're both pretty simple lessons and work well together. So we're going to try and speed through them and get them done in one day. So lesson 4.1 is about constructing and interpreting scatter plots. So at the end of lesson 4.1, I want you to be able to say, I can construct a scatter plot and use it to understand the relationship between paired data. In the interest of time, we're going to skip this page and head right to the example. So go ahead and turn the page. Example 1, Luciana analyzes the data collected to determine how long after posting a new blog her new homepage received its maximum number of new views. Her data are presented in the table. How can she determine whether there was a relationship between the time after posting and the number of views? So she's looking at time after posting and number of views. So you can see down here her x-axis is time and her number of views is y. So she's looking at this x and y data. So they showed us in step 2, well, step 1 says draw a scatter plot. So this is one of our vocab words. A scatter plot is a graph in the coordinate plane that shows the relationship between two sets of data. Step 2 is to plot the order pairs. So at time is 2, number of views is 350. So I go to 2 and here's 350. There's where they put that point. Then 6 and 50. Okay. 1 and 500. And all the rest of the dots. So Luciana can use a scatter plot to determine whether there is a relationship between the two data sets. And we can see as time goes on, the number of views actually decreased. It goes in like a pretty steady rate. We can follow the dots. Try it. Luciana collects data about the number of entries and the ages of the subscribers who enter the concert giveaway. The point that represents the data in the fourth column has the coordinates. So we're going to look in the fourth column. Here's 1, 2, 3, 4. So the coordinates are 13, 9. So it's just asking you, can you look at a column and make the x and y values out of it? So explain how Luciana would choose scales for the x-axis and y-axis. We can see that our x's are just between 10 and 15. So I would say she could count by 2s. And the number of entries is 8, 9, and 10. She could count by 1s. Okay, example 2. Interpret a scatter plot. Rochelle asked 10 friends how many hours of sleep they got the night before a math test, and then matched that data with their scores. She plotted her data in the graph below. Did students who slept more get higher test scores? Look at the way the data points are clustered. If the y values tend to increase as the x values increase, there is a positive association between the data sets. That's one of your vocab words. If the y values tend to decrease as the x values increase, there's a negative association. So a positive association, if you're looking, it looks like this. It's going up as we go towards the right. That's positive. Negative goes down as we go towards the right, reading left to right, just like you do a book. So a cluster is a group of points that lie close together. A gap is the area on the graph that contains no data, and this point is offset from the other data points. It's an outlier. So this is a cluster because they're really close together. This is a cluster, they're close together. Here's our gap where there's no data points. And this guy, he's an outlier. He's by himself. He's sad. Construct a scatter plot. Avery is a middle school basketball statistician. She tracks the number of minutes a player plays and the number of fouls a player makes. Her data are shown in the scatter plot. Is there an association between the number of minutes played and the number of fouls made? If you look at all those dots, they're really not in any sort of trend. And it says the y values do not increase or decrease as the x values increase. So the scatter plot shows no association between the number of minutes played and the number of fouls made. Let's try it. Avery also tracks the number of minutes a player plays and the number of points a player scored. Describe the association between the two data sets. Tell what the association suggests. We can see kind of as we go left to right, if I drew a line like that, all the points are generally around that line. So that is a positive association because as we read left to right, it goes upward. So that association suggests as the minutes increased, so going back to can you read the graph, as the minutes increased, the points increased. Okay, so I just looked at the axes for that. Minutes played. As the minutes played increased, so did the points scored. All right, 8th grade, let's say it for this lesson. I can construct a scatter plot and use it to understand the relationship between paired data. So let's skip ahead a few pages. Oh, I forgot to do the key concept. Sorry. Let's do this really quick. Scatter plot shows a relationship or association between two sets of data. So this is positive association because it's going up. These were a cluster because they were close together. This is negative association because it's going downward. Here's our outlier, our guy that's outside. Here's our gap where there's no data. And this is no association because there's no trend, no constant pattern. So now skip ahead to lesson 4.2. Analyze linear associations. By the end of lesson 4.2, I would like you to be able to say, I can use a line to represent the relationship between paired data. So again, we're going to skip this page, go ahead right to the next page. Example 1. Georgia and her classmates are measuring their height and arm span. They record the data in the table. How can they determine what relationship, if any, exists between the two sets of measurement? So again, we're trying to look at the height and the arm span. Height comes first, so that's going to be on our x-axis. Arm span is going to be on our y. And they plotted the points in a scatter plot. It's called a scatter plot because the points are kind of scattered a little bit. It's not in a perfect straight line. But then step 2 says use a pencil to find a line that passes through the middle of the plotted points. This is called the trend line. So you kind of just try and draw a line that fits most of the points. All the points are really close to those. Then you want to look at the slope of the line. The slope of that line is positive. So her trend line shows a positive relationship. It's going up as we read left to right. Let's try it. Georgia and her classmates also measured their foot length. Use a pencil to find the trend line. Sketch the trend line for their scatter plot. So it's a sketch, so they're really there is a right and wrong answer, but there's a little bit of leeway. But it looks like most of the points are around that line. So again, it's a positive relationship. But this makes sense. Think about it. As you grow taller, your arms get longer, and your feet get longer. It's proportional. Someone who's taller is going to have longer or bigger feet than someone who is shorter. Example 2. The strength of linear associations. The Johansons own an ice cream shop near the beach. The scatter plots show their sales by daily high temperature. They compare their sales by daily high temperature to the number of beachgoers on a daily high temperature. Describe the association shown. So there's two types of associations. We already said there's different types of associations. You can have weak, you can have a positive association, you can have a negative association. Now we're going to describe again those associations, but we are going to add a description, weak or strong. So if you think strong, you're going to think of someone that's really tight together. It's like a strong bond, or a strong rope is really tight together. Something that's weak is a little bit more loose. So here, if you see where the trend line is and all the dots, they're near the line, but they're really not really close and tight to it. So this shows a weak association. But here we see the trend line. All those dots are really, really close to the trend line. Don't worry about the outlier. The outlier is okay. Leave them out there. But all the other points are really, really close. That's a strong association. Example 3. Recognizing nonlinear associations. So it says, does the scatter plot show a linear or nonlinear? Well, the word linear literally has the word line in it. So a linear association has a straight line. A nonlinear would be curved. So here, this has association. Like, all those dots show a trend, but it's not a straight line. So that's going to be nonlinear. Let's try it. For each scatter plot, identify the association between the data. If there is no association, state so. So we're going to look here, and this looks like it has, if I draw my trend line, first of all, is it positive or negative? Positive. Is it strong or weak? Strong. All those points are really close to it. And is it linear or nonlinear? Linear. Next. Ooh, this looks like it's a circle. So it's a circle. So we can't really say if it's positive or negative. We can't really say if it's strong or weak, but we can say that it is a non-linear association. And the last one, does that have any kind of correlation to it? Nope, there is no association. It's not positive, it's not negative, it's not up or down, strong or weak, it's just all over the place. All right, key concept. Scatter plots show a linear association, a nonlinear association, or no association. For scatter plots that suggest a linear association, you can draw a trend line and show the association. And then you can assess the strength. Is it weak or strong? By looking at the distances of the plotted points from the trend line. So here, strong, positive, and weak, positive. You can see the strong, the dots are all real close. Weak, the dots are far away. Here's nonlinear, because the dots show a trend, but it is not in a straight line. All right, 8th grade, let's say it. I can use a line to represent the relationship between paired data. Hey, thanks for sticking it out with 2 lessons with me. Proud of you guys.